All right, we're going to today take a look at section 12.2. It's titled Angles and Angle Measure. Angles and angle measure. First thing we're going to do is we're going to talk about just sketching or drawing angles in standard position. I guess I should say draw the angle in standard position, not an angle. Might make more sense. Come on. We get it. I don't know. Okay, draw the angle in standard position. Let's start off with a 70-degree angle. We're gonna draw it or sketch it in standard position. So what that means is we're going to start off with an XY axis. We're going to graph it or draw it here. An angle we know has two sides, two rays. In standard position, the first side, we'll call it the initial side, will always be in the same spot. That's on the x-axis to the right of the origin. So the first side of our angle is always going to be right there. And we'll call it the initial side. And then from there, we'll go to our terminal side. We call the other one the terminal side, but we have to travel 70 degrees first, and you'll go in a counterclockwise direction. So we're going up. 70 degrees, it should be about roughly there. It's just a sketch, it's not going to be perfect. Notice I drew the angle, I put the little arrow on there too down below, so you can show where it's going, and then I draw the terminal side. That is an angle in standard position. So we'll do a couple more. Let's go with 225 degrees. Terminal side, or the initial side rather, is always in the same spot. And then we have to go 225 degrees counterclockwise. So go up, there's 90, there's 180, and then it's 45 degrees beyond 180. So we end up in quadrant 2 right there. That's how we would show a 225-degree angle in standard position. Let's do a negative one. Let's go with negative. Actually, let's go negative 400 degrees. I don't like my initial purple line, I guess. It's not very straight. I'll just try this again. Okay, so initial side will be right there. What do you suppose is going to happen if we're going with a negative angle? Any guesses? We go clockwise. We go the opposite direction. 300 60 degrees is a full circle, and we're going more than a full circle, you might notice. So I will go all the way around, and then how far past? 40. So I would draw it this way. You start to spiral. So that way you can show how many revolutions. You don't just draw right over top, the arc on top of the previous circle. Just kind of spiral it so we can see about where we're at. And we have our terminal side. So with the other direction, full revolution, and then 40 degrees past. What would happen if I went, let's go 320 degrees, positive 320? What would that be? Counterclockwise, not quite all the way around. How far shy? 40 degrees. How does that compare to the last one? We go the other direction, but where do we end? Where does our terminal side land on both of those two? Is it the same place? Yes, we have a name for angles like that. If the terminal side ends in the same position, we call them coterminal angles. The vocab you want to be familiar with. Angles, and specifically angles in standard position, but angles whose terminal sides are in the same spot. Oops. Or same position. Their terminal sides are the same. That's kind of the idea. So, for example, we have this negative 400 degree angle, and we have a positive 320 degree angle. What are maybe some other angles that would also be coterminal with those two? What are other ways we could go to get to that same spot? One revolute, what's that? Say it again. Oh, sorry, but I mean to these two, coterminal with these two. What's something that's coterminal with 320? Is 360 coterminal with 320? No. What would be something that is coterminal with 360? 640. So there is a proposition that 640 would. Is that true? I hear yes, I hear no. Oh, the proposal came from somebody who now believes it's not correct. 680? We've updated it to 680. Do we believe that to be true? How do we know it? I agree it is. So 680 is coterminal 320. How? So we added 360. So we added an exact revolution, nothing more, nothing less. So it will end in the same spot. What's another one? What's a zero would end on the actual x-axis. Would negative 40 would be, right? Negative 40. If we went in a negative direction, but not a full revolution and then 40, just going 40, right? Anytime you have one of them, I mean, that's the smallest positive one for this particular angle is 320, right? Anything smaller than that's negative. But anytime you add or subtract 360 or a factor of 360, sorry, not a factor, a multiple of 360 is what I meant to say, would give you another coterminal. So if you add 360 to 320, we get 680, that's one. If we subtract 360, we get negative 40. If we subtract 360 again, we get negative 400, etc. You can continue to do that over and over again. But all of those angles whose terminal side ends in the same spot are coterminal. All right. So that's kind of the the sketching an angle piece of this section. We're going to now really talk more about angle measure for the rest of this lesson. Let us consider a circle whose radius is 1 unit. Sometimes we call this the unit circle because the radius is 1 unit, so it's a unit circle. Maybe some of you learned a little bit about a unit circle in geometry. But if I wanted to, instead of kind of traveling from the center of the circle out to the circle, if I wanted to start walking around or drawing around, tracing around the circle, that same distance as the radius, which was 1, I would end up somewhere around there. Okay, that arc, we call that an arc there that I have in orange. If I make it the same distance as the radius, we would get to about there. If I continued to draw those, how many, do you know how many of those it would take to go around a full circle? About 6? That's pretty close. It is not exact. It is less than 7. It's between 6 and 7. Anybody remember talking about it in geometry last year? 6.25 is getting really close. 6.28 is better. But what's 6.28? It's approximately double of pi. That is exactly right. It would take, to go a full circle, it would take 2 pi of those. Do you know what we call one of those? We actually have a name for it. One, so if we're traveling around and we go the same distance as our radius, we call that a radian. You may remember on your calculator, we had to make sure we were in degree mode. The other mode was radian mode. It was talking about these. That's about the length of a radian. And it takes 2 pi radians to equal a full circle, or 360 degrees. Oftentimes we'll use pi with radians. We don't have to, like here was actually 1 radian without a pi, but a lot of times we talk about in terms of pi because a full circle is 2 pi radians. What would be 1 pi radian? How many degrees would that be? 180 degrees. Half of a circle is a pi radian. That right there is something you want and need to know. But hey, what if I went all the way down to just a single radian, which is what I have shown on the circle right now? How many degrees would 1 radian be? Around, I mean, we could give approximations. I care about trying to be pretty exact. If I took the equation above it that I have circled, what would I have to do if I went from pi radians to 1 radian? What operation, mathematical operation did I do? I divided by pi. So what would I have to do on the right side? Divide by pi. So if I took 180 and divided it by pi, and I'm not asking for approximation. We don't actually have to do the division. You could see what it is about. But that's the size of a radian. So about 57 degrees, roughly. That's not nearly as important as knowing that pi radians is 180 degrees. But a radian is about 57 degrees. Think for a moment, I want to connect this to circumference. Because we're starting to go around, we're traveling around. If we travel all the way around a circle, isn't that called circumference? What's the circumference of this circle? How do you find circumference? Pi r squared is area of a circle. 2 pi r is correct. So we would do 2 pi times the radius. Our radius being, didn't I give it a radius of 1? So 2 pi times 1 is 2 pi. That's the circumference of the circle, is 2 pi inches or whatever we're talking about. But isn't it also 2 pi radians around a circle? Is that any coincidence that that's the same thing? No, it's really not. Because radians is really kind of talking about distance around the circle. It's a little bit different. What we're going to do now, and this is hugely important in the next section, especially. It's not just the next section, but understanding this will be really helpful in the next section. And I'll give you a heads up when we get to 12.3, and that's not till after spring break. But when we get to 12.3, we're actually going to take a quiz over 12.3 4 days in a row. Maybe even 5. One of them might be a practice one. But you're going to be given like the same quiz over and over again, 4 or 5 times in a row. And the goal, the idea is by the end of that, hopefully you're really good at it and you're getting 100%. What we'll do is we'll take the 2 best scores and we'll end up using those. But if you can understand what we're going to do now and this connection, I think that's going to be really helpful when we get to that section. So that's a little ways out, but hopefully it gives a little bit of significance to what we're going to be practicing right here. What I want to do is I want to make sure that you're good at converting back and forth between degrees and radians. And to do that, I'm going to set up and think about some triangles. Really, it's our special right triangles in each quadrant to think about how many radians each of those measures would be. So when we think about special right triangles, we just did the worksheet on it. We had 30 and 60 and 90, and we had 45, 45, 90. So let's think about 30-degree angles for a second. If I drew a 30-degree angle in standard position, it would be this, correct? Be about there. I would like to know, and I'd like you to be very proficient at being able to determine how many radians that is. But remember that 180 degrees is the same thing as pi, right? What portion of 180 is 30? Isn't it a sixth? 30 is a sixth of 180, so then isn't it also a sixth of pi? Pi over 6? 30 degrees is equivalent to pi over 6 radians. Now you'll notice after 30, I put a degree sign, I put my label. I did not put a label after pi over 6. Technically, it's pi over 6 radians. But you will rarely or probably never again see me actually give it a label of radians. And I wouldn't expect you to very often either. When we're talking, I'll probably say it. But typically, if we see pi there, we assume and we understand that it's talking about radians. So very rarely will you actually write the word radians, but it's understood to be radians. Now, so that was a 30-degree angle right there. We're going to see as we get into that, when we get into that next section, that we can look at what we call reference angles and other quadrants. And the reference angle will always measure it from the x-axis. So that's getting a little bit ahead. Let's get thinking a little bit about next section. But I would like to make a connection between this section and that section. So if I have another 30-degree reference angle in quadrant 2, it would mean it's that line right there. Well, how many degrees from standard position is that angle actually? If I measured all the way from over to here, how many degrees is that? It's actually 150 because it's 30 degrees short of 180, isn't it? So that's actually a 150-degree angle. 30 we know is pi over 6 radians. And if 180 degrees, if all the way over to here is pi radians, and I come back 1/6 radian, What's 1 minus 1/6? 5/6. So that's actually equivalent to 5 pi over 6. Now, do I expect you to memorize that 150 degrees is equivalent to 5 pi over 6? I don't expect you to memorize that. I don't have that memorized. I wouldn't be able to rattle it off that fast. And we're going to add a whole bunch of these on. If that's all it was that one, then yeah, I would expect you to do that. But there's going to be a bunch of these angles. So what I would expect you to do is remember that that's 30 degrees or a sixth of shy of pi. If we went 30 degrees in the next quadrant, that would put me about there. What standard position angle puts you in that spot? 210 degrees. Because you would go to 180 and 30 more. Well, isn't that a pi plus a sixth of a pi? What's 1 plus 1/6? I prefer improper fraction, be 7/6. So 7 pi over 6 is the radian measure of a 210 degree angle. If I went to the fourth quadrant, the 30 degree reference angle puts me there. 30 degrees shy of 360, right? This is 360 degrees. If I went all the way around, also known as 2 pi. But if I stopped 30 degrees shy, I would be at 330. How many radians is 330 degrees? It's less than 2 pi, because 2 pi would be the full 360. I have to come back 1/6. 2 minus 1/6 is 11/6, so 11 pi over 6. Once again, I don't expect you, I'm not going to ask you to memorize those connections. But if we're thinking about 30 being 1/6 of 180, then we should be able to come up with those pretty quickly. Well, 60 degree, when we had a 30, 60, 90 triangle, 60 was another significant angle. So let's talk about 60s. What portion of 180 is 60? Third. So we could say that 60 degrees is the same as pi over 3 radians. If I go to quadrant 2, that's 60 degrees shy of 180, which is 120 degrees. How many radians would that be? So this over here at pi would be, or 180 degrees would be pi. So I'm shy of pi. Isn't it 1/3 shy of 1 pi? 1 minus 1/3 is 2/3. That's 2 pi over 3. I'm just thinking of thirds. 60 is a third of 180. So if I go backwards here, really that's what I've done. I've gone back 60 degrees, or I've gone back, I've subtracted a third of pi. So 1 minus 1/3 is 2/3. Now, if I go into the second or the third quadrant, haven't I added a third to my pi? So I get 4/3 there. How many degrees was that? It was 180 plus 60 is 240 degrees. And when I go to the fourth quadrant, so if this is a 60 degree reference angle, I've stopped 60 degrees shy of a full circle, or 60 degrees shy of 360 is 300 degrees in 5 pi over 3. And then 30 and 60 weren't our only special angles, but so was 45. Pi is 180 degrees, 45 is 1/4 of that. So that means 45 degrees is pi over 4. Those first quadrant ones are really important to remember. Remember that 30 is a sixth. Remember that 60 is a third. Remember that 45 is a fourth. If you can remember that, I think you can make up or you can figure out the rest of these. So if I go into quadrant 2, I've now gone 45 degrees shy of 180. So that's 135 degrees. How many radians? So here would be a pi. And I'm how much short? I'm 1/4 shy of 1, so that would be 3/4. So 3 pi over 4. When we go to the third quadrant, that's 180 plus 45, that's 225 degrees. How many radians? 5/4. So pi plus a fourth is 5/4 pi. And then in the last quadrant, 315 degrees. If I subtract 45 from 360, that would be, yes, 7 pi over 4. Those are pretty important to remember, or at least be able to figure out. You don't memorize them. I wouldn't bother. I've never done it, never will. So don't recommend that you spend that much time doing so. The other piece of this is the actual 90-degree angles. This right here is 90 degrees. What portion of 180 is 90? It's a half. So it's pi over 2. 180 degrees is pi radians. The next 90-degree increment is 270. How many radians would that be? 3 pi over 2. And then if you go a full circle, you're at 360. Also, it's coterminal with 0. Gone nowhere. How many radians? 2 pi. Also coterminal with 0 pi. So those are important and significant angles. If you look at your textbook, you'll see all of those in one spot, all in one circle. Sometimes, in geometry, I know in my last class, some people said they used the unit circle a little bit in geometry. If you've ever used the unit circle, it's really just all of these put in one place. I'm not going to print out unit circles and have unit circles for you. Some people do. It's not a bad tool. I prefer, though, to think about, thirds and sixths and fourths is my personal preference. But you will see it in your textbook if you do so. But the one last thing I want to do today is actually use those to do just a few random conversions. So it's really no different than what we just did there. I'm just going to ask you to convert to the opposite measure. And when I say opposite measure, I just mean degrees versus radians. So if we have 7 pi, obviously that's in radians. How many degrees would that be? What would I do? Mathematically, what's going to happen if I want to know how many degrees that is? Pi is how many degrees? It's 180. So I can think of this as 7 times 180 degrees. Calculator for that one. We get 1,260. But if I give you like 7 pi over 3, I know you could find it over here on the picture that we just drew, or actually no, this one goes beyond 2 pi. You could figure it out there. But here's how I would recommend doing this. Most of it I'll do mentally, but this first one I'll kind of map it out and show you my thought process. But I like to isolate that 7. Pull that 7 apart. And think of it as pi over 3. So it's really 7 pi over 3 is the same thing as 7 times pi over 3. What is pi over 3? How many degrees? 60, because pi is really 180. So 180 divided by 3 is 60. So it's really 7 times 60. What's 6 times 7? 42, so this would be 420 degrees. What if we had 5 pi over 3? I'm thinking of that as 5 times pi over 3. Pi over 3 being how many degrees? 60, because it's just a third of 60, or third of 80, sorry, 180. So that's a total of 300 degrees. Three pi over 4. What's pi over 4? That's 45. Pi over 4 is 45. So what's 3 45s? 135. And then lastly, to finish this off, what if we went the opposite direction? What if I gave you degrees? We'll go easy first, 360 degrees. 2 pi, good. 2 pi radians, don't even bother with the word radian, we could. Oops. 120 degrees. 2 pi over 3, that was pretty fast. So I would think of 120, it would be on the left side of a graph. So when I compare it to 180, it's 60 degrees shy of 180, so that's a third. It's a third shy of 1, 2/3. You can think of it that way. All right, we have a little bit left to finish on Friday. We'll finish the last couple things. The assignment that's on the calendar, you should be able to start on that, but it does continue with tomorrow's section. So there's an assignment for all of 12.2, and we've covered most of it at this point. Just not quite all of it.